Okay, good afternoon, everyone, and welcome to the inaugural lecture in our 2014 Distinguished Lecturer Series, sponsored by Yahoo, who's been a long time supporter of the campus. They're a gold level sponsor of these Distinguished Lecture Series, and we're very thankful to them for their sponsorship. Today, it's my great pleasure to introduce a colleague and friend, Ticky Thakkar, from Intel. Ticky's been with Intel for 21 years and has seen the company through several major changes and shifts. He came in and one of his first great accomplishments was architect of the P6, the post-Pentium processor, the Pentium Pro, which introduced big system architectural concepts like register renaming and deep pipelining into what were then just desktop architectures and radically changed the microarchitecture climate for Intel. He's also known as the father of Centrino, bringing wireless connectivity together with chipset and processor technology inside Intel. He's highly influential. His style of operating is to work closely with customers. I had the good fortune of working closely with Ticky back in the days when I was at Nokia and we were trying to drag both companies kicking and screaming into the Intel mobile world. So maybe we'll hear a little bit of that today. Ticky's here to talk about his vision for pervasive mobile computing. Let's welcome Ticky Thakkar.
Thank you. So thank you, Bob. And let's just kind of maybe spend a few minutes here just talking about a little bit of what's happening to the industry and how things are changing. I've known Bob for forever, and it's since his days at IBM. We had shared memory workshops that he attended, and I started some of those in the early years of shared memory computing, and then recently, and then I also knew him at DEC as well when he was at the DEC team running some of the alpha development, and then recently, really. My relationship started with him with Nokia and working at Nokia, where he was the CTO of Nokia at the time, and we met in Helsinki and Tampere and all those places in Finland and in Palo Alto, and all those memories are still vivid and very warm, and we've kept in touch over the years, and so I'm very thankful for the opportunity to talk to the team here. Also very excited that some of the things that he was talking about during the time at Nokia, he's actually trying to make it happen here. Some of the embedded system vision, sensor vision, and I just this is ours is a relationship that has also spanned through what's happening in the computing industry through a number of years, right? And if you look at what's happening, it's very fast evolving things. I remember being at Sequent in the early 80s or the mid 80s, and dramatic shift was happening, with shared memory computing coming into play. And I remember Ken Olsen calling it boutique computing, the Sequent computer systems that we were designing, and they and the history. DEC got swept out of the VAX, and they were the dominant machine of the time, right? And it just got swept out, right? Same thing happened to Sequent. Sequent, started to replace the mini computers with their machine. Originally was designed for really for what do you call for high performance simulation environment, and that actually didn't work out. What worked out was it was a great transaction processing system, and Oracle and Informix at the time joined us, and Oracle actually really made the hay out of it, and then people like Siemens came in, and so this is a multi-user system that can replace the VAX type systems. So again, sweeping things happened there. What Sequent missed, and I was working there before I transitioned into Intel, was the transformation of that was getting commoditized, especially the four-way servers and stuff. were getting so cheap with Windows NT coming on it. It was going to be dirt cheap servers going to be out there, and these things still exist. These dirt cheap servers, right? And I accelerated that by going into Intel and making the P6 into a four-way MP. And now you have the evolution actually, where four-way MP is on a chip, single chip, right? It's inside your phone, four-way MP today. So I mean that's how the transformation is happening. Um, the um, the next set of transformation happened for me was the laptop and the beautiful thin and light laptops you use today. Intel made a dramatic change, from saying, hey, we're not going to put the desktop computers inside the laptop and kind of voltage scale them down because they don't go far enough. And I was at one of the meetings earlier on at one of Intel customers, and the person threw, who was a GM, threw in a shoebox in the middle of the meeting room, and he says, "Intel, if you don't change, what you're doing, the power supply is going to be as big as a shoebox, and it was true. I don't know if you first generation Xbox, you remember the power supplies were as big as a shoebox, on there, right? And so we made a dramatic change. Instead of trying to voltage scale a 75-watt processor down to 45 watts, designed it for 20 watts, and thus were born the thinner and lighter laptops and wireless connectivity and driving, improvements around the platform to reduce the power and stuff, right? And then if you look at what's happened after that, about almost 4 years after that, I picked up some of the things, and we started saying, hey, we wanted to create an ultra-mobile computer inside your pocket that was also your phone, potentially, but it was a 5-inch or a 6-inch machine, and the first generation was called the ultra-mobile PC, and that's ultra-mobile PC, and I was just talking to Bob, that it wasn't designed, you couldn't, run some of the things that you wanted to run in the form factor, even though it had a great web experience, because if you think about 2005 timeframe, or 6 timeframe, the du jour experience on the screen was a web browser. It was a crap browser, I would call it, not a web browser, right? Because you couldn't get, the websites were terrible and stuff. So our goal was to bring an internet desktop or device that has the same experience as you get on your laptop. Everything would just work seamlessly, right? And so was born, this, we called it the ultra mobile, the mobile internet device in the time when we started working with Nokia. And most of the people, at the time didn't have that vision, of what this could be, because the phones were very tiny, 2.5-inch screens and all of those things. And we said, nope, people will want to have 5-inch screens. Well, we were wrong at the time in terms of how small those screens will come down. But if you look today, most of the screens of the smartphones are 4.7 to, and then, if you go to Asia, they use this term phablets, which is really, phone tablet-like machine, which is about 5 to 6-inch machine as such. But that vision of trying to bring mobile internet device was born during the early years, and we started to drive Intel architecture into that. And that was the relationship with Nokia and some of the other folks. As you know, Intel was also working from Steve Jobs' book with Apple as well at the time. So I think the evolution is happening, to bring really stuff onto your handheld devices. And now you're seeing another set of disruption is happening in this class of devices. What you've seen, these devices, and we'll start the talk in a minute here. Clearly, Apple's done a fantastic job in being the integrator and providing a fantastic experience on their device. And Android is also, Android-based phones, you buy Galaxy or one of the other devices, they're all catching up and delivering a great experience, but they're still doing email primarily. They're doing the video playback. They're doing some graphics and browsing. And then of course you play music as well. If that's the only thing you're going to do, um, you're going to see another wave of disruption coming in, where the Chinese industry, China industry, as I was talking to Bob, there are 10 players there who are producing semiconductors now that are going to compete in this space. And they've shipped, more silicon in this area than some of the established players like Intel in the last year, and especially in the tablet space. Um, we have to innovate to figure out how to make these devices be better than what, just do those things that I just talked to you about. And really, I want to kind of talk about, okay, where do we go from there? Okay. And so my talk is a dialogue, and I expect to have conversation with you rather than a monologue, in this discussion of where we want to talk about and where we want to go. So some of the vision and challenges is really the focus. So as I said, if you look at it today, HD TV, HD playback, I use it quite a lot, because when I work out, I want to see TV shows, and that's the only time I actually watch TV shows. Personal navigation, rich gaming, social media, etc. And this stuff is really, I would say, changed the way we live in this world. And let me give you an example. Last year, I was in China for a visit, and my wife suddenly couldn't come. And I'm married to a Chinese person, so I was expecting her to come with me to Shanghai and stuff and spend time with me there, because really she enjoys it more than I do, even being there. So one of the things, I kind of wandered around. I didn't have much to do at lunchtime. I just worked out. I said, hey, there's a nice brunch down there in this hotel, and it's a nice hotel, and they had a opera singer singing, and it was a Western opera, not the Chinese opera, but they had a beautiful Chinese lady singing and a man singing, a lot of the famous songs, from the Western operas and stuff. And it was still, about 10 o'clock at night or something, for US at the time. And I had an iPad with me, and I called her and said, are you awake? He says, yeah, I'm awake. I said, you got to hear this, right? And I put this thing on live, because I was connected to Wi-Fi, and I said, can you listen to this stuff? And she was able to enjoy the same experience while not being there, right? And I think this is wonderful, right? We are able to have that experience and being able to use the mobile device in that, it was, you call it collaborative, but it's really sharing an experience, right? Same thing, my nephew got married, and I took a picture while the wedding was going on, and I posted it, on the website, on my Facebook, and suddenly I had pings from my other cousins who couldn't be there, saying, "Oh wow, I'm missing it," blah blah blah, right? But it's sharing the experience, and that's what made possible with what we do today. And I think this is going to get, and I mean, and certainly as the teenagers and many other people share a lot of the experiences on the Facebook to make things happen. So where do we go from there? And really, if you look at it today, these devices are getting more and more intelligent. They have so many sensors embedded in it. They have sensor processors embedded in it. You've seen it in Apple's case. They produced one last year. In the 5S has a sensor engine, and I think more to come. And this year, and they're going to get more and more low power, more what do you call more accurate, and how often, always sensing is currently. If you do always sensing with these kind of sensors, you'll turn your phone into a brick because they'll consume so much battery. So they're going to get better with all of this stuff. And the kind of things you can sense is also going to improve. But the things like augmented reality is something which really excites me because this is, and when people talk about augmented reality, you always think about, somebody watching a Golden Gate Bridge and then the machine recognizing this is a Golden Gate Bridge. Or the worst one I've seen is people show, front of Mona Lisa and showing that more details about, oh, this is Mona Lisa's picture and recognizing it. But if you've been in front of Mona Lisa, you can't stand there more than 10 seconds before somebody pushes you, right? So, so, but that's kind of view of augmented reality people show. What they don't show and what they don't talk about are the opportunities that are possible. So, for example, I think it's Porsche or Audi has introduced a new app that runs on the tablet. They've got rid of all of their manuals. So the engineers are trained, their mechanics are trained to walk around when they introduce a new car, they upload a new app, updated app with that new model, and they walk around the engine compartment. The tablet recognizes each pieces, and then the engineer can hit the piece and say, not only it can show you what that piece is, but it can give you more details and animation of showing how you can pull that thing apart, etc., and put the thing back together. To me, that's the critical thing. You can't do that with your laptop. You can only do it with a mobile device. And I think those kind of things are going to become very, very important, right? Lego has one of these things that they put in the store where the kids take a box in front of this machine, which is actually a PC, and it actually shows what you can build out of that box, right? And so kids can show these things, that this box you can build this kind of nice, maybe one of the Millennium Falcons or etc. With this kind of Lego box. So the stuff is intelligence, it's recognition, it's applying, in fundamental ways of doing things that's going to change how we do things, right? It's well beyond, playback and social media and all of those things. It's actually very, very different way of how things will change in the environment we kind of work with, right? And, there's a number of things, and a lot of these things are in the way. I mean, multiple HD cameras. These are going to happen, by the way, in the platforms that are coming out. Digital signal, audio processing is already there. Sensors, as we talked about that, low power wireless, etc. So there's a lot of opportunity of what's coming, and I think this is on the way. This is not something that is going to happen 10 years from now. It's going to happen now, right? Some of the things that we need to, and I think, just walking into, Bob's lab, we had a lot of those kind of sensors that monitor today, the light, UV, etc., right? What are the things that are going to be needed is some fusion algorithms of making sense out of those sensors, right? And then really driving the appropriate usages out of those things, right? So all of those things, just really about to change the kind of things where it becomes the device is growing towards being an assistant to you rather than a tool, right? So this is the first time the whether it's a phone or a tablet, they're going to become kind of more intelligent and help you do things. And this is just basically going from an accelerometer to really inferencing is the critical piece here, right? So recognizing doing something, raw data, and what you're doing, whether you're running, sitting, walking, depending on the different things here, whether you're chatting, listening to music, commuting, those are the things that are going to really matter the most. And these are things that we have to do to figure out, how we're going to make sense out of the sensors, I would say. So that comes to the wearable devices, and I want to kind of give you some examples of wearable devices. And you know, several of you may be wearing the Nike's Fuel Band. Very cool device. I got this thing as a present a couple of years ago from my wife to make sure that I walk enough, because at Intel there's a tendency, and for a lot of us guys, to have a tendency to sit too much in meetings and not walk enough, right? And it's made me very conscious, and I strive to do at least get over the minimum, the goal that I've set, right? And it makes me feel good, at least that I'm healthy, and it actually changed my behavior as well in what I do. I'll try and hit those goals, regardless, right? So it's made me conscious. What the pain with this device is, and it's getting better, is that it doesn't proactively tell me anything. It's a passive device. I have to press a button. I have to do things to tell me what it actually does. And when I was in China, here's the thing, there's a nice app on here, but the app has to go work in foreground. And when I was in China, to sync up this thing with the app, you needed a server, Nike server up as well. Well, usually by the time I do it, it's nighttime and the server is in service, so you can't even sync the thing, right? The stuff, and this is where it irritates me in terms of, hey, there's so much potential out of this stuff, right? That we're not even thinking about it, and really requires a full end-to-end service that you can make it much more proactive. It telling me I need to do something, it telling me to do, make a change in my habit would be, and enforcing it by even buzzing on my hand would be a more important stuff. The other one, which I want to kind of talk to you about, is I wear hearing aids. And by the way, these hearing aids that I wear are ultra cool hearing aids. And I didn't realize, first of all, I was in denial that I had a hearing problem, right? I couldn't hear some people, and especially wife talking, couldn't hear it. And then it turned out, then it turned out that it's the women's voice is in certain pitch level that apparently it clips it. And so I had an excuse to tell us, look, I really couldn't hear it. So now she makes me wear the hearing aid. But anyways, the really cool thing that happened with this was this device. Now this device is a wearable as well. And I bought it it connects my hearing aid to my phone. And I can actually now have a fantastic voice call, but it's like, there's a little microphone in here. So this is too big for its actual use. And this is not, by the way, this is not just a wire to hang it around my neck, so it's convenient. This is actually a body network. Yeah. The hearing aid, the wireless is, you can't put Bluetooth in your hearing aid because it's too high power and it's too, what do you call, a Bluetooth LE cannot, for example, transmit voice. And so to transmit voice, you need to be low power, so this has to be very close to my hearing aid. And then there's a Bluetooth in here that transfers to this device here, right? And then there's a little microphone. So fantastic voice calls, right? But that's not the coolest stuff for this thing. One day I was kind of driving and I hit the button, twice because I thought I had just wanted to click the phone. I'd done with a phone call, and it brought on Siri and said, "Hey, what can I do for you?" And so first it was just a shock, it's like, what the hell happened, right? And then I kind of got, hey, this is cool stuff, I can talk to Siri just by hitting my button here, and the thing would be sitting somewhere else, right? And I had turned, the next time it kind of freaked me out was, I was driving somewhere in Bay Area and on Lawrence, and I turned on the navigation, and it was the Apple navigation system, which has turn-by-turn, driving feedback, right? So it told me turn right, and I just again, just completely out of the blue, it freaked me out. It says, "Wow, the computer is just talking to my head," and I actually like that too, right? So, and right, because now I can get a driving, nobody can tell I'm making a mistake. And so my wife says, "Is she talking to you?" Right? So because when we go, I just turn on the driving instructions, and I'm just being driven, by all these things. But what it shows you is an opportunity where the device is effectively talking with you, in very without any kind of obvious that in a ways, right? I mean, I could be getting feedback if I program this thing, an app, to give me feedback about my biosensors and stuff, right? Um, so the opportunity to do things now is huge, right? And the other one, which kind of which is making more exciting stuff, is this um, ingestible computer, right? Which is with sensor, you take this pill and it goes down, and people wear a patch around here, in their body that would transmit to their phone, right? And it would give, reports out. And then there are things which are going to be embedded inside your skin. For elderly people, it would actually not only monitor their life signs, but actually release medicine potentially at the right time because they are prone to forget things and stuff, right? So you could really, really change life, lifestyles, and you could make a huge impact on how we behave and how we, change our lifestyle. And this is one of the things I say to my team at Intel is whenever we start a new project, we say, well, how is this thing going to change somebody's life? Whatever it is that we're trying to do has to have an impact to people's life. Well, here's an opportunity where we have the beginnings of pieces, right? We have the wearables, we have the phone, we have, you know, potential body networks that can talk to things, right? Um, to deliver stuff, we really need to have number of things happen, right? This is just kind of talking about some of the capabilities. But if you look at the opportunities to do things, what I call quantified self-usages, it's endless in different areas, right? For wellness, for disease, management, and we did some brainstorming of how people would use this thing in our team, and I couldn't stop people thinking about how many potential uses could be for this kind of technology, right? What you do need is really, as you can see, there's many sensors, right? They need to communicate. You're not going to put on those sensors, and I think Bob had this right in his lab today. You're not going to put in those sensors all kinds of high-powered wireless capability and stuff. And I also like what Bob was talking about. He was talking about that the cost, and I actually showed this with you here, is that the power of sending bits out to somewhere is very expensive, right? In terms of power and cost as well, right? So you're not going to put wireless capability of big sensors and 3G networks and stuff on all of the stuff around your body. It's just not possible, right? You're going to run out of power, if you do that. And you need to do some level of computation and stuff that needs to happen, right? Closer to that environment, right? Um, and everybody's going to carry one of these things, right? And we are going into more and more powerful computing in here, right? Quad core, computers in a phone, right? They're here today, right? And or 64-bit engines in the if you take the Apple's machine, or any of the Intel machines, phone machine. All our architectures are 64-bit, right? So there are very, very advanced capabilities available here. So you can do local computing even from your body in here and provide feedback there, right? And you can synthesize some of the, what you learn from all of those different sensors, from the sensor fusion algorithms, etc., and actually, supplied inferences back to the person and update whether it's a doctor or the hospital services or the Nike sensor server that is monitoring in here, right? So this is the kind of vision we have that we think that's likely to happen because of all the things that matter. As I said, you need to have different classes of wireless to be able to share the different at different levels the sensing. The other piece is also that I think there are a lot of sensors. I mean, this thing, some of these things now have GPS in it. My phone has GPS. Does everything around there need GPS? So I think there's also opportunity to share things as well in those kind of environment. So I think this is basically just showing, there are things you would give feedback to the user instantly, and then there are feedbacks that you may want to provide to the backend. But all these three pieces are needed to really provide that service that you want to provide to the user. And this is just more example of, what you would have to do with the cloud services. And what are the things you would need? Bob, you have a lot of this stuff working in your lab, in terms of the stuff you were demonstrating, that some level of operating system and some level of processing capabilities that you need to provide in those areas, right? So from my perspective, the research challenges are really, the body networks, for example. I think there's a lot of opportunity to do better body networks, for example. And in different applications, I think, Bob, your team is providing the short-range radios and all of those capabilities that we talked about, right? Machine-to-machine communication. I think this is super important because at the moment, everything that I just showed you is explicit communication. I have to hit a button to communicate, right? Now, if I had, and you'll have this capability of continuous sensing very, very soon in these class of devices. Low power, continuous sensing, what are the things, why can't these computers talk to each other and actually provide the experience you need to provide to the user, right? And then the pairing and all of those things today is very explicit, right? We have to pair and enter even stupid things like 0 on both sides, which shows that, there's no security and stuff, right? For Bluetooth pairing and things. You could make it far more intelligent than it is today. And especially if you have hundreds of sensors around your body, are you going to pair all of these things, with, it's very, very silly, right? So we need to figure out how we're going to make those things much, much easier than they are today, right? And so I think, to me, having the ultra low power wireless capability, having ability to the machines to talk with each other so that you can relay important information back to the servers and provide proactively some feedback to the user, and then really some level of framework, which, as I walk in here and maybe, Bob and I have a relationship, different relationship, it says, hey, did you know Bob has some new things? Because our machines talk with each other and they exchange information because Bob had given me that level of privilege to see that information from him. But, for somebody complete stranger, you won't provide that access, right? So I think these are kind of things that are really, really hard problems at the moment. And these can't be proprietary. This has to have complete interoperability for it to be successful, right? Um, you you cannot this cannot be anything but standards based, because you have to have standards for those things, and they have to be very useful. You can work. It has to work across devices. And then if you look at where we're going with um, you're going to collect lots of data. Even from a single human, the data was going to be overwhelming, right? So you're going to need the learning capabilities, right, for each of these things. You need to have data fusion capability, because you're going to use the sensor of the heart versus, some other sensor uh, to make inference of what's happening to the person, right? For example. Um, so you need a way to classify things. You need inferencing algorithms, and then really figuring out what you do local versus what you do, at a cloud level is another piece. And where you cross the different boundaries, because, and I think Bob talked about this thing as well, which is that if you uh, you have to be careful how, for example, the communication happens. If one node is broken somewhere in your sensor network around the body, that doesn't mean that you have nothing going out, right? So there has to be some reconfigurability, and then also making sure that now you reconfigure, you're not burning out another sensor around, that's going to be passing the information back to the system. So reconfigurability, local versus kind of cloud-based computing, all of these things have to work together to kind of really drive the next vision of mobile computing as such. And then you have to also look at the ecosystems that's going to be around, right? You'll have to go drive the ecosystem, because not everything that I just talked to you about exists, right? It's in pockets. The biosensors, and they are all, they're evolving at their own kind of space, and they're also evolving in their own ways. So there's no standards today of one sensor talking to another sensors, uh, and if you want to drive some level of standardization, that's going to be very important. The other thing which some of the people I've known have brought some really good idea about energy harvesting. Can we charge, my hearing aid type stuff, which has very, very tiny battery, by the way, because it's so small, first of all. And some of these things are actually embedded. I just couldn't think about sticking things in my ears that I can't pull out and stuff, right? So, it just freaked me out. But those things are going to require some level of charging. If you're going to use this as a kind of an augmented personality of person, and we can put it in a bowl to charge or something like that, and it's good. But I think you need to kind of think through the next level. Can we use maybe the cellular energy to charge some of this device? Because whenever you're using this phone, it's generating some level of energy to talk to things. And so there's a potential to charge the small devices and stuff. Again, this is another set of things that you'll have to go drive, is the interoperability with the backend stuff. It's a huge task to deliver this class of services that we're talking about, and you'll have to kind of have standards in the backend, so that this interoperability happens with the class of services you want to provide. And then my final thing is, how do you debug problems when they happen, which are, has a chain of things here, right? When they don't work, how do you know they don't work, right? Even in the device, that's, let's say, the thing which, just freaks me out is how are you going to debug the ingestible device, which is going in your body, right? And maybe it didn't do something. Well, there's no way to probe it. It's inside somebody's body, right? So there's going to be some standards that we have to invent, right? That's going to send some protocol to that thing. Maybe it's woken up, and to me, it's very similar to like sending signals to things going to Mars, right? And you're not going to touch it or anything, right? And you need to be able to debug it, right? Um, and then, of course, the device form factors and packaging, from anybody who's building silicon or devices. I mean, this is going to be very, very interesting. Um, and I know the one company that had the chip inside a capsule. Well, how do you protect the ingestible from whatever, collapsing and your body just killing it, somehow, right? So these are, to me, some of the challenges as we kind of come to this next set of kind of what I call pervasive computing, right? And I haven't talked about the infrastructure and stuff. I mean, there's also notion of that these desks will have, sensors and computing capabilities and displays and all of those things. But to me, that's just another dimension in this whole thing, right? I'm just giving you a dimension which is kind of more around a person and mobility, but walls and all of those things can also have sensors, and you can interact with those things as well. I'll stop here. I did monologue almost, so we'd like to kind of inject thoughts and questions and stuff. Uh, yeah.
Take of those who we might be recording, I'll have to run around with a microphone so that we get it. Do you mind asking your question again? Sorry.
Sure. I was just hoping to hear some more information on security and how that trades off with the ease of use and interoperability demands.
I'm just trying to think through some of the things that, I'm currently looking at some of the security for the enterprise class devices and stuff. Oh,
Yeah, don't mind
right.
us.
Okay.
Go ahead.
Right. Yeah. And I think this is a very, very kind of interesting subject at the moment. I don't have answers for all of those things at the moment, in terms of how you're going to manage those things. But you have to really protect the person, right? Because you want to make sure that the data just doesn't from somebody's body doesn't go somewhere, in somebody's hands, right? And suddenly your insurance company says, "Hey, I'm going to increase your rates because you are in an unhealthy state or something," right? And they got your data through the sensors. So I think um, there has to be security of the device. There has to be a security of the infrastructure, and I think those are two different things. I think security of device is something we'll have to kind of figure out through the exchange that we talked about. How is the data exchange between, let's say, the phone, let's say, which is your body hub, call it, right, versus with the what you're collecting from the device, and you'll have to develop some protocols to kind of protect the data that's coming in. We know how to do secure pairing and stuff today. Once you have that, the data is now put in there. Now, we also know that you can create containers to save that data in some parts of the system that other stuff can't get to it, right? So as you have an open system, and wild west of any app coming in and grabbing that data. So I think what you need to do is encapsulate it into some area. And by the way, this is very possible today. We're looking at it all the time in terms of protecting corporate data in that way, but there's no reason why the personal data can't be protected in the same way.
The table microphones are enabled, so if you when Ticky calls on you, if you just push the button near the microphone that's closest to you, it'll work.
Yes, you have those buttons.
Yeah, I'm seeing all kinds of things I completely agree with. Machine-to-machine communication standards. I'm wondering what your thoughts are on what the implications of this evolution from, say, standalone apps or something to sort of intercommunicating apps and networks, home body networks, whatever. Do you think universities like ours are teaching the right things, or are we missing some things in terms of preparing students for this kind of vision?
That's an excellent question. And so I saw some things Bob showed me in the lab, and with embedded systems, and so I'm very hopeful that some of the things that you're looking at it from a system perspective of how you deal with an embedded device. I'm very hopeful of that piece. Um, what I think it's missing is probably the vision of the complete end-to-end capability, right? Are we looking at all the pieces and are you making the right trade-offs and stuff? I don't think so. I think that's missing today. And that specific vision uh, of how do you create the whole end-to-end capability and where are the trade-offs being made, right? Because I can assure you that this device maker had no more trade-offs thinking, for example, let's just take Nike, than saying, oh, I'm Bluetooth connected to that. After that, it's okay. Now, think about a scenario where now I'm continuously sending data to this device, and you nail this guy down so that, when the user looks at it and says, gosh, my battery is half, right? Where did that trade-off happen, right? Because I don't think it happened here, and it didn't happen this guy, right? So I think thinking end to end is going to become very important of where you make trade-off in communication, power, computing, where you do those things. And I think that requires a full view of the problem you're trying to solve.
I can do follow. That's a great question. And it's actually strongly related to the one that I was going to ask you, which is in today's economy, traditional semiconductor players and computer manufacturers and others are increasingly facing horizontalization, meaning that they focus on a slice of the problem. And as you articulated, the interesting thing really is vertical, right? It's an end-to-end system problem with trade-offs and the possibility of making decisions about where work gets done. So the question is this. Given that Intel undoubtedly has a financial incentive in making sure that this reality comes to pass, what is the form of the research institution that actually can carry forward significant vertical systems kinds of research? Does it look like a startup? Does it look like traditional university research, traditional corporate research, or something different?
It's a very interesting question as well, which is different variation of are you teaching the right things. And I think really the place where I think this has to happen, it can't be a startup. And here is the reason why my thinking is. Startup has to focus into one thing and do one thing really well. And here there are many moving parts, right? There's the device, there's the phone, there's the back-end service, and in the device there's tons of sensors that are going to be around people's body and God knows what, right? In terms of a lot of capabilities, right? And I think, and then the kind of things we need to do here and the problems we have to solve are the trade-off problems at the system level, the trade-off problems at the what do you call application level of computing and stuff. I think from my perspective, universities or the standard-based world is universities where you create the standards to do these kind of things, right? The ARPANETs and stuff wouldn't have existed if it wasn't for universities and the DARPA work that was done by DARPA and stuff, right? And I mean, Linux or Unix came out of the university environment, and I think if you look at some of the standards have grown out of universities and such, right? But you have to become relevant in this area. The universities have to start saying, hey, this is the problem to solve, and start putting effort, teaching. Research has to move away from kind of maybe the iterating on the current type of stuff to, hey, different kind of stuff that has to happen. And I think your problem you mentioned, decomposable app, which is really app from several places are working on something together. All of those things I haven't seen. I've seen some research labs and corporation doing it. Intel has done some of these areas, but I think it has to be collaboration of, it has to be driven out of university and then driven into the areas. Now, who in an industry is going to make something out of it? As a player. Today I don't see anybody there. I mean, Apple is a very nice vertical player that does these things. And then, you've seen Google do things, and the beauty with Google is the openness and standards. And if I look at Nike, Nike is doing some of these things with the devices. By the way, there's also, I mean, I've had discussions not just with Nike, but bodysuits are going to come in because they are going to be another set of things that are. And by the way, the reason bodysuits are going to coming in is not because the level of accuracy, especially the athletes are going to use them first, and the level of accuracy of this device is not very good. You put it, I have to put it on the shoe. And by the way, I talked to the Nike guys, and they say, yeah, shoes is the best place to actually sense what you get out of these devices, right? In terms of how much energy you're burning. So you don't have one player doing all of those things today, and unless maybe Nike starts to do it, and they're going to provide it for their athletes, this whole service that are going to go and then proliferate it to the mass public. You were next.
Yeah. So one of the challenges we've seen in the industry, I've been both in industrial research for many years. It's fun. Super fun. Seems effort that somebody can stick with it.
And I think it has to happen in collaboration, and this is where I agree with Bob. It has to happen in collaboration with industry, right? Whether is it the Nike, or is it the device manufacturer or the silicon manufacturer like Intel, or is it vertical players like Apple who has a phone thing? But I think it has to be in collaboration with those people, right? And you have to kind of bring those people in and say, hey, we want to provide this stuff. And my take is that manufacturers of devices are going to provide the end-to-end service, which is going to be, maybe it's Nike, for example, who sells the bodysuit, provides the full end-to-end service. And maybe that's the people you collaborate with or something. Next question.
So we do the bodysuit stuff.
You do bodysuit? So maybe I'll take a look at it. Then.
And,
Yeah.
well, Intel is funding a little bit of it too, so thank you.
Great. Great.
My question is that in wearables, because we have to deal with humans a lot of focus has been placed into sensor. And in infrastructural sensor networks, a lot of work has moved to include things like actuation and things like that.
Mm-hmm.
What are your thoughts on actuation in the wearable domain?
Maybe how would you kind of rephrase that question for me? Maybe it'll help me better.
So I think the work is really just pure sensor. They only take in information and inform people in a sense like a database or something. But do you see any possibilities or maybe future where actuation, like direct human actuation? We already seen some of that. Like the pills and they inject some medicine. But what are some of the domains that mobility would need actuation?
Are you talking about collecting data and inferencing from it, and applying it back or something?
Applying back to
Yeah, I mean, so somehow you got to provide some feedback to the user, right? Is that kind of, is that what you're talking about? Sure, sure. So one of the simplest one is, for example, vibrating, this device, right? So different kind of vibration tells me different messages, right? Without me looking at it, if I were trained and it says it vibrates for this duration, well, maybe I take a walk, maybe I do something else, right? I think those are going to be extremely important, right? Right. So you absolutely go to provide the biofeedback to the person, and I want to get out of a space where I don't want more data. I want more right, relevant information to me, right? I have enough data coming to me, right? And things I care about, from this class of device that, makes my day is it shows, at the end of the day, am I beating, which is a recent thing Nike's added, for example, is also that I'm doing better than my age group, right? The amount of energy I burn. That really makes my day, right? Yeah, yeah. No, it's a very good question. And again, I think we're at a tipping point, right, with some of these technologies. Um, I think we're at a tipping point of collecting data, and then I think it's a question of where the computation things are getting done and what inference, because the sensors before used to be, I have lots of sensors data collected, right? So a lot of things. How do I process the data and make something out of it and produce something quickly, right? I see more and more sensors are going to be used in different environments today. And I think we're at a tipping point, maybe within a year or so, where the sensors are just going to be embedded everywhere that you're talking about, right? Um, I I have I mean, that's how I'm feeling. Maybe I'm too much in the Kool-Aid place where, I'm drinking my own Kool-Aid, but I'm to a point where you think that the people are not manufacturing these sensors, or the demand will grow for this different sensing.
Well, I used to also work in industrial research with people who created lots of scientific instruments. So
Mhm.
I know what was possible a decade or so ago, which was very tiny
Yeah.
sensors. And so I'm starting from a simpler premise of sort of, having been a parent, I could have bought a little sensor pack that would detect, you know, lead, other kinds of environmental toxins in the air, which were easily sensible.
Mhm.
Um, you know, for various reasons, I think lots of people would like to be able to occasionally take measurements of blood chemistry, other kinds of things. That the computation involved is not really very big to
Mhm.
do that. It's
Mhm.
basically the sensing, AB transduction, a little bit of analytics that produce a
Right.
metric.
Right.
But we haven't seen those kinds of very straightforward products emerge, even though they have been possible for a while now. So I wonder, um, is that something that is simply appealing to people, not an intermediate step until we can get to this kind of world, or just your thoughts on why that
Right.
we
So
haven't seen that at this point?
yeah. So one time one of the things that I was led into this equation of why industry may not get involved in various things, right? And then the computation became like, um, let me kind of lead you through this thing. It was this problem this person was trying to deal with. It was supposed to help a certain set of people, right? And then in industry they calculated, okay, so how much units that will you actually help me sell this widget to, right? And it's maybe 10 million people, because that's how much people suffer from this potential disease or something, right? Well, there are 4 billion people in the world, or 5 billion, and I'm going to make something that's only for 10 million people. So some of those equations of those classic kind, which prevent those innovations to really take real root into solving the problem. When you go, where I think that the inflection point will happen is when masses, are going to benefit from it, right? And when you have masses benefit from it, then I think it drives the economies of scale, and somebody's interested to make money out of it. And I think that drives, and maybe that's going to also drive the kind of the sensing capabilities to become cheaper and more economical and more embedded into the classic devices. But it's a very cruel world, by the way.
We
from
have
that perspective.
somebody online with a question. So Ruben, if
Sure.
you can click the box and we can get the question. Or not. While we try to get that figured out, why don't we take one more question
Well,
from the
there was one
room, and then we're
question
going to
out
have to
here.
break.
Sure.
Sorry. So, just a question. So, with the ecosystem that you described here, and I guess maybe this is related to, how would you see modifying that for use in, say, like developing regions where people can certainly benefit from the technology, but there's not the infrastructure and the back end to support that, or cell phone costs 3 months pay, or there's not electricity that they would charge you even if I do have one? What kind of applications would you see that could potentially help those folks benefit?
Yeah, so I think this is very cool, because I had some folks working in the research lab in India at Intel, and they built some sensor pack that could actually attach to a phone, and this sensor pack would monitor, could measure um, what do you call heart rate and breathing patterns and stuff, and they were trying to in fact provide some kind of local diagnostics, for doctors in villages, and because they have villages. I'm not grown up in India, but I can imagine how this could be used. I actually grew up in Africa, but it can easily applied, into the African village. Not every village has a doctor, and if I now have to provide somebody, just kind of do a quick checkup on the person, and I can use this sensor pack, which had basically a heart rate monitor, some basic capabilities of do a vital signs check, and it can be done by a doctor remotely. That's it was something very economical, because the sensor packs are very cheap to make, and now you're providing a capability that would never have existed before, and the cell phones are very prevalent. So the connection was Bluetooth based, but I could easily see, being audio jack based, for some of the things, because the bandwidth isn't that, big. But since Bluetooth is very pervasive, they just built with the Bluetooth. So I think there is a lot of opportunity to use this, because this is disruptive technology. This is not, laying phone lines and all of those kinds of stuff. The sensors are cheap, they're getting cheaper, and I think the opportunity to do good is huge. And reaching people that couldn't have been reached before, right?
Ruben, can you bring up that question that came up online? Nope, can't do it. All right, so apologies, Sam, for some reason we weren't able to get your question. So Ticky will be available outside, I think, for questions, and we can set up some additional discussions. But let's thank our speaker.
Thank you. Thank you. Thank you very much.